Hello everyone, so today we will be going over the names and structures of carbohydrates. So what is a carbohydrate? A carbohydrate is a large group of organic compounds including sugars such as monosaccharides and polysaccharides. So these both over here would be sugars. Now, what would be the general formula for sugars? So the general formula would be this right here. So this is the general formula for carbohydrates. Now let us analyze the structures of these carbohydrates. So most sugars will be chiral and optically active. By using the Fisher projection, we can compare the two enantiomers of 2,3-dihydroxypropanol, also known as glyceraldehyde. So if we take a look at the first enantiomer, this would be the same as writing it as okay. Now if we look at the second enantiomer, it would be the same technique as this, in which we also write it with wedges and dashes. Okay, now you might ask, why did I write it in wedges and dashes? So, if we look back at the original structures, we could see that this vertical structure with the CHO and the CH2OH, this represents a dash line, which means that it's pointed away from you. Whereas this structure, which has the H and OH, which is a vertical line, represents the structures that are pointed towards you. And therefore, this structure and this structure would be the same. And this structure and this structure would be the same. Now let us take a look at other structures these sugars can exist as. For example, sugars could be epimers in which they have different configuration in just one chiral carbon. So let's take a look at glucose and the epimers of glucose. So if we write out the epimers of glucose, okay, now let's take a look at these two structures. So where would the different configuration in just one chiral carbon be? So a chiral carbon, if you didn't know, is the central carbon in which there are 4 different groups. Okay, now that in mind, let's look at where the different configuration would be. So right here would be the same. You have CH2OH. Right here, H is on the left, and right here, H is on the left. So that would be the same. These are the same. These are the same. And right here, we could see that the H is on the left, but over here, the H is on the right. So this would be where our chiral carbon is different, and therefore, this chiral carbon and this chiral carbon has a different configuration, and therefore these two structures are epimers. Sugars can also exist as constitutional isomers. Constitutional isomers have the same molecular formula but different bonding. Now let's take a look at these 3 sugars. Where would there be different bonding? So if we look from bottom to top, we can see that these are the same so far. Okay, now they're the same right here. But then when we hit this bond, we can see right here there's still an H and OH, and here there's an H and OH, but here you have a carbonyl. So then from that, you know that for this structure, it has a different bonding, but the same molecular formula because they all have the same groups. And therefore, this would be the constitutional isomer.